Welcome to the fourth section of this choice board, which covers orders of operations. My students like to call this section the one where we get to play hopscotch. And I always felt like every section was really fun and exciting, but my students told me that this one was definitely more fun and exciting than other sections, mainly because of the hopscotch. When we move to orders of operations, most people have learned that from the thing on the right, which is called PEMDAS. You'll see PEMDAS frequently written like this. I prefer to actually move the M, the D here, and then the A and the S together. Because in orders of operations, what each of these things stands for is P stands for parentheses, which actually should be all grouping symbols. Parentheses, brackets, absolute value signs, they all should be included on this top part. The second part here actually stands for exponents. The M and the D stand for multiplication and division. Running out of room. And we talked about in class many times that multiplication and division are actually the same mathematical operation. So they shouldn't be one after another. They should be at the same time. You treat them equally, as do you treat addition and subtraction the same. We look for addition and subtraction exactly the same. Addition does not come before subtraction. And the reason why we have to do orders of operations is every mathematical problem has to be written in the correct order of operations. And an example problem would be something like this. 3 minus 6 times 4. If I wasn't working on this through the correct orders of operations, I would do 3 minus 6, which gave me negative 3. And I would do negative 3 times 4, which gave me negative 12. But if I write it over here on the right, and I do it in correct order of operations, multiplication and division come before addition and subtraction. So I would do 3 minus 24, which gives me an answer of negative 21. And if you notice, these are not the same. Orders of operations matters for every single mathematical problem. So remember to always work out problems in the correct order of operations, which is what we're learning right now. Now, PEMDAS is more commonly used, but I like to use a strategy called OPHOP because it gives me an excuse to do hopscotch in math class. In hopscotch, our little person is standing down here, and we're working our way through. The first box in hopscotch, we call it G for grouping. You notice already a big difference. Grouping covers parentheses. It also covers brackets, absolute value signs, square roots. Anything that deals with a grouping sign is the first thing that we have to target, not just parentheses. You land on one foot here. You jump into the next one, which is E for exponents. This is exactly the same as PEMDAS. Exponents always come after grouping symbols. Then you jump on 2 feet together, left to right, for multiplication and division. You always want to do the left side multiplication before the right side multiplication. But once again, multiplication and division are done at the exact same time. And then the last two are for addition and subtraction. I apparently think subtraction starts with a D, which it does not. And once again, you land on these at the same time, not separately. Addition and subtraction are done together. So PEMDAS on the left, OPHOP on the right are equivalent. You can choose either one, and I just ask you to have to do OPHOP once in class with me before I'll let you move on. For a few examples here, when we work through these problems, once again, the first thing we want to do is anything inside the parentheses. As I work through these problems, I always want to do one step at a time. So I'm going to do the left side parentheses first. That's this one. And then I will do the right side parentheses second. That's the one on the right. Now, in this parenthesis, I have subtraction and I have an exponent. Exponents come before subtraction, so I will do that first. Everything else will stay exactly the same. I will only do one part of this problem at a time. So now I still have a parenthesis over here, so I will do that next. 0 minus 81 is negative 81. And I still have this parenthesis on the right. Now, this parenthesis on the right actually doesn't impact the problem at all, but the exponent still does. So I'm still going to do 3 cubed, but negative 3 cubed. Negative 3 times negative 3 times negative 3 is negative 27. So I will do negative 81 divided by negative 27. So for our final step of this problem, we know that this is a positive 3 because negative 27 times positive 3 is equal to negative 81. So that is an example of a problem, one step at a time. Step 1, we did 9 squared to get 81. Step 2, we did 0 minus 81 in the leftmost parenthesis and got rid of the parenthesis, negative 81. Step 3, we did the right side parenthesis and got negative 27. Step 4, we landed on our answer of positive 3. For the next set problem, we immediately see grouping symbols. Once again, we have parentheses. We're going to do that right away. So we get negative 13 plus 19 is positive 6. The rest of this problem will stay the same. And now I want to do the leftmost multiplication, because we have multiplication and division. They're the same, so we want to go left to right like we're reading a book. 13 times 6 is the same as 10 times 6 and 3 times 6 added together. So that would be 78 divided by negative 6. And our final step is 78 divided by negative 6, which is negative 13. So that is our answer to this problem. Once again, one step at a time. 2 left. Now, I talked about before that any grouping symbol can be included, and that includes absolute value. But we have parentheses inside of parentheses, because these are treated the same way. You want to go to the innermost parenthesis first. That means our first step is we're going to do negative 4 squared, which is negative 4 times negative 4, which gives us positive 16. So I do plus negative 18. Now we know plus and negative is the same thing as minus, so I'm going to change it to minus 18. Leaves absolute value, and we're going to do times. Absolute value of 7 is just 7. If you remember, absolute value means the distance away from 0. Since distance is always a positive number, you will simply leave it as a positive. Okay, so in this case, we have 16 minus 18 inside the parentheses or grouping symbols. So that is negative 2, still under absolute value, times 7. Now, the absolute value of negative 2 is asking us how far away from 0 is negative 2? Well, the answer is positive 2. So our last step is going to be positive 2 times positive 7, which is a positive 14. One more problem. Here we have extra sets of parentheses again, so we're going to do the leftmost parenthesis first, which gives us negative 3 cubed. If you remember from the first problem, negative 3 times negative 3 times negative 3 again is equivalent to negative 27. We can get rid of the parenthesis now, which means we have to do, for the second step, the second parenthesis, which is negative 3 times negative 1, which gives us a positive 3. So our final step of this problem is negative 27 times positive 3 for an answer of negative 9. Remember, if you didn't score a 4 out of 4 or a 3 out of 4 to do the retake video, as always, if you have any questions, please let me know as soon as possible. And remember to do your op-hop with me in class before you start any assignments.